midpoint and trapezoidal sums. Okay, the first problem is approximate the area between the x-axis g of x from x equals 10 to x equals 16 using the trapezoidal sum with 3 equal subdivisions. Okay, let's see. So this is the first subdivision, this is the second subdivision, and this is the third subdivision. Okay, so let's start. So for the first subdivision, we have 2, and then we're going to multiply that by 2 is the height, because a trapezoid on the x-axis looks like this, please. So yeah, if we flip this around, it would look like this, right? So this point and this point are the same, and it represents the height here, so the x-axis in this case represents the height. And we know that the distance between 10 and 2 is 2. 10 and 12 is 2. And now we do 5 plus 1 divided by 2, because we do base 1 plus base 2 divided by 2 to find the average of the bases, and then we multiply this by the height to find the area of a trapezoid. And so yeah, and so this over here, this would represent the base, and this 2 would represent the base. And so here, pretend like this is 10 and this is 12. So then this would be 5 and this would be 1, even though the heights don't correspond like that. So anyways, I hope you get what I'm trying to say here. And then we're going to do 2. Then we have, well, I'm just going to do 8 divided by 2, which is 4. And then we have 2 times 7 plus 7, 14, 7. Yeah, so let's do this. So we have, so the first one is 6 divided by 2 is 3, 3 times 2 is 6. We have 4, 4 times 2 is 8, and then we have 14. Yeah, and so we get 14, 14 plus 14 is 28. Let's see if we're correct. Yes. Approximate the area between, okay, let's use, no, I'm going to use blue this time. From x equals 2 and x equals 6 using the trapezoidal sum with 4 equal subdivisions. Okay, okay, maybe I'll try to draw it out here. So, because we're saying from 2 to 6, 4 equal subdivisions, that means each subdivision is going to have a length of 1 unit. So yeah, so this will be the first subdivision. This will be the second, third, and the fourth subdivisions respectively. And if we draw a trapezoid, so this is base 1, this is, oh my goodness, base 2, and then I'm just going to draw a line, kind of looks like a trapezoid. Here's my other trapezoid, and then my third trapezoid, and then I'm not even sure how I'm going to draw a trapezoid here, but trapezoid. Yeah, so we have the distance is 1, so we don't, so the height or the distance between the x1 and x2 is 1. I'm just not going to even write it because it doesn't matter. So base 1 for this is 3, and the second base is 7. So we have 10 divided by 2 is 5, plus 7 plus 6, 13, 13 divided by 2. And then the last, well, second to last, we have 6 and 4. We have, okay, 10 divided by 2 is 5. I'm just going to write 5 plus, what is this? 4 and 4. Okay, we have 4. I got 4 because I did 4 plus 4 divided by 2 equals 4. Yeah, so I'm just going to plug this all in. So I'm just going to type 14 and then 13 divided by 2, which gives me 20.5. 20.5. let's just take a look at what they did. Determine the width of the trapezoid, determine the input values, evaluate the area. We want 4 equal subdivisions. Yeah, their trapezoid looks like a rectangle. Okay, yeah, this is what I tried to do too. Yep, they did exactly what I did, and they got 20.5. So from -2 to 2 using the trapezoidal sum with 4 equal subdivisions. Okay, this is where we start, and this is where we end. 4 equal subdivisions, which means the width is going to be 1 unit. So let's start. So base 1 for the first one. Okay, we can't find it here, so we have to plug it in ourselves. So yeah, if we plug in -2, we're going to get 1/4 plus 1/2 divided by 2. Yeah, I'm going to let the calculator do all the work. And then we have 1/2 plus 1. Plus 1 divided by 2. And then we have 1 plus 2 divided by 2. And that's a plus sign here. Plus 2 plus 4 divided by 2. And I got this 1 by 2 to the 0th power is 1. Then this 2 is because 2 to the 1st power. Yeah. So plugging all of that into a calculator. So let me see if I can zoom out because I can't even see a thing here. Okay, there it is. 1/4 plus 1/2. We're going to divide this entire thing by 2. 3/2 divided by 2 plus 3 divided by 2 plus 3 because 6 divided by 2 is 3. Oh, we got 5.625. Okay. 5.625. I'm getting so dependent on this decimals. I don't even know how I'm going to do the AP exam. Approximate the area between, okay, from this point to this point using the midpoint. Oh, okay, midpoint Riemann sum with 3 equal subdivisions. Okay, I don't really like the midpoint sum, but hey, we have to do it anyways. So if we have 3 equal subdivisions, I mean, you could do 0.5 minus 3.5, and then you would get 3. 3 divided by 3 is 1, so the width would be 1 unit long. So this would be 1 subdivision, 2nd subdivision, and the 3rd subdivision. And the midpoint of these 2 areas would be this. So this is the point we care about now. This is the point we care about now. This is the point we care about now. Okay, so let's start. We have 1 times 3 plus 1 times, I think that looks like a 1. 1 plus 1 times, where is this? 2, okay, 2. So 3 plus 1 plus 2, 5, 6. Let's check.